In this video, we're going to be using some factoring methods to help us factor and solve quadratics. So we'll use a factoring technique where we take out the greatest common factor, and then we'll also use what's called X factor. And it's just organizational tools that we can use to help us factor and solve quadratics. First thing we need to understand is how to multiply two binomial expressions together. A binomial is an expression that has two terms. Prefix bi means two, nomial means terms or numbers. So an expression with two terms or two numbers is a binomial. So here's a binomial in parentheses right here. And then it also has another binomial here. So here are two binomials, and we're going to try and multiply them together. Whenever we do that, one way or one method to use is called FOIL. It's just an organizational method to help you remember to multiply each piece of our binomial. FOIL is an acronym that stands for first, outer, inner, and last. And so that's just the order in which we multiply to help us stay organized. So when we multiply the first terms, we're multiplying the terms that are in front of our two binomials. Then we multiply the outer terms, the terms that are on the outside, together. Then we multiply the inner terms together. And then we multiply the last terms in each binomial together. And when we do that, we should multiply all of our pieces together. There'll be one additional step. We'll see what that is in a second here. So here we have two binomials. We're going to practice foiling or multiplying them together. So I'm going to multiply the first terms, x times x, and I get x squared. Multiply the outer terms, so x times 6 is 6x. And then the inner terms, 3 times x is 3x. And then the last terms, 3 times 6 is 18. Whenever you FOIL or multiply two binomials together, your first and last terms are not going to be like terms. They're going to stay separate, but your middle terms are going to be like terms, and you're always going to combine them. So that's your last step, is to combine your middle terms. 6x plus 3x gives us 9x, so here's our final quadratic. And anytime we multiply two binomials together, we get a quadratic expression. There is another way that we can think about distributing or multiplying two binomials. You can use boxes. If you use the numbers or terms in your binomial to represent the side lengths of each box, then we have x and positive 3 here and x and positive 6 here. And foiling or multiplying them together is really just finding the area of each individual box. So x times x is x squared, 3 times x is 3x, x times 6 is 6x, and 3 times 6 is 18. And then these diagonal boxes are going to be your middle terms or your like terms that you combine. And then we should end up with the same quadratic after we're done. So either way you want to multiply binomials, using the FOIL method or using the box method, that's up to you, whichever you prefer. What we're about to do is work that backwards. So we're about to start with a quadratic, and when we factor it, we're going to end up with two binomials. And one way we can do that is this organizational method called the X factor method, where we draw an X and we just put some numbers in some spots to stay organized. It's just an organizational tool. Up top in our X, we're going to multiply our A and C terms, and we're going to write that value up top. We're going to write the B terms value down on the bottom. And we're going to play a little game where we find factors of the top that add up to the bottom, or factors of A times C that add up to the B term. And we're going to put those on the sides of our X's. So let's do an example here. We're going to factor this quadratic expression into two binomials. So we're going to take our A term, 1, and our C term, negative 12, multiply them together. We're going to write that value up top, so negative 12. Anytime A is 1, you're just going to write your C term, but I don't want you to get used to that, because in the next video, when we have a number that's bigger than 1 up here, we are going to multiply A times C. So just get in the habit of multiplying A times C, regardless of the value of A. We're going to write our B term below, which is positive 4. And then we're going to ask ourselves, what are factors of negative 12 that add up to 4? Or in other words, what are two numbers that multiply to the number up top that add up to the number on the bottom? Well, 6 and negative 2 multiply to negative 12, and they add up or combine to make positive 4. So we're going to take 6 and negative 2, and those are going to be the numbers that we put into our binomial expressions. So when we factor a quadratic, we're going to write two sets of parentheses. The variable is going to be the first term, And then those side factors right there that we came up with are going to finish off our binomials. So positive 6 and negative 2. It doesn't matter what order you write your binomials. So if you had written x minus 2 in front and then x plus 6, that's all good. You can always check your factoring by foiling and going back the other direction. So if we FOIL these two binomials, x times x is x squared, x times negative 2 is negative 2x, x times 6 is 6x, and 6 times negative 2 is negative 12. Combine our middle terms, and we get that positive 4x. So we can check our work, make sure that we get back to the original quadratic, and we can be sure that we factored correctly. So when we take the sides of our x's here and we just put them into the binomial expression, it seems kind of magical, and it is kind of magical because we are missing some middle steps there. So when our a term is 1 and we use this factoring method, we're kind of skipping some steps, and it's kind of a shortcut, but you're allowed to use it. In the next video, we're going to describe those missing middle steps. So for now, just take factors of a times c that add up to b, and put those numbers into your binomial expressions, and that's the factored form. Let's try it one more time. Let's factor this expression. So a is 1, c is 6, so 6 times 1 is 6. I'm going to put that up at the top. My b term is positive 5. I'm going to put that on the bottom of my x. And then factors of 6 that add up to 5, or two numbers that multiply to 6 that add up to 5. That would be positive 3 and positive 2. So I'm going to put x plus 3 in one binomial and x plus 2 in another, and that's the factored form. We could FOIL to check it, and we should get back to that original quadratic. We can use this factoring method to solve, and there's just one additional step. Once we get to this factored form, we're going to do what's called finding zeros of those binomial expressions, and I'll talk about what that means when we get there. So let's do those first two steps we just practiced. Using a different quadratic. This time it's an equation. We're going to factor and solve this equation. So we'll just look at the quadratic expression and factor it. A is 1, c is negative 12. So I'm looking for factors of negative 12 that add up to 4. Eventually you want to get away from using that x and hopefully be able to just look at a quadratic and factor it into its two binomials, especially when a is 1. And this is just a pretty simple quadratic. So factors of negative 12 that add up to positive 4. That would be positive 6 and negative 2. So we write those numbers in our binomials. And here's our last step. Because our quadratic is set equal to 0, we can find what are called zeros of the expression, which is essentially just setting each of these binomials equal to 0 and solving. So 0 times anything is 0. So if x plus 6 equals 0, the whole thing equals 0. Or instead, if x minus 2 equals 0, then the whole thing equals 0. So we have two possibilities. One shortcut you can take when you have these basic binomials is just to say, what is the opposite of the number in front of me? That makes 0. Opposites always make 0 when you combine them. So the opposite of positive 6 is negative 6. But you could also get there by solving this equation and subtracting 6 from both sides. Same thing over here. If you add 2 to both sides, you get the solution positive 2. You could have got that by just looking at your binomial and saying what's the opposite or what makes it 0, positive 2. So you have two solutions, negative 6 and positive 2. Doesn't matter what order you give your solutions in as long as you have them all. And you can always substitute solutions into your equations to check your answers. So if you substitute negative 6 into both of these x spots and simplify your expression, you should get it equal to 0. Same thing if you substitute 2 into either of those inputs. Should simplify and equal 0. Let's try it again. This time we have a quadratic that's not in standard form, so we're going to put it in standard form by adding 24 to both sides, set it equal to 0. We're going to find factors of 24 that add up to 11. That would be positive 3 and positive 8. And then we just look at our expressions here, our binomials, say what's the opposite or what makes it 0. Or we could set each of them equal to 0 and solve it algebraically. So we get the solutions negative 3 and negative 8. I'm going to continue these notes in a separate video.